Ivo, can I borrow your? Okay, let's start our section today. So for those who don't know me, I am Vinh Đăng. I'm one of the responsible lecturer for course, especially for simulation and case study. So today is our third instruction section. So in this section, we will study about events, simple events, but we also will learn more or some additional features of simple store. The learning outcome of today is still we develop simulation model for using language of Python. And after this lesson, you are able to, I expect you are able to use the feature of SimByStore for modeling share buffer. And you can also define and use SimBy event for process interaction. To achieve that, we will go through the agenda today. First, we have a recap of the homework. Then we will do some exercise on stores, followed with a short break. Then we have practice exercises on events, and we have a summary at the end. 5 minutes before the lectures end, I will deliver kind of index card for you. Just ask you to write down some feedback for the instruction section, so that I can use for that to improve it next year. So first, let's proceed to the homework. Last week, we have learned about different types of shared resources. We have 3 types of shared resources: the normal resources, like operator, machine, robots. We have store, literally is a buffer in practice, and containers. You can think of fuel tank or liquid tank. We practice the 2 first type of shared resources with the job shop setting. So first we model the job shop problem, then we add robot for transporting robot between the machine you see in the figures. Then we add the buffer with the finite capacity, and we can see additional robot capability manufacturing with the machine. The last two sub exercise 2.3 and 2.4 are your homework. So, is there any question for the homework? Yes, please. Yes. It's very large. Yeah, but it's not sufficient. It's not sufficient. It's not efficient, right? Because if you add very large, you take space. If you just use minimum amount of the slot, you design a minimum slot for the buffer, it doesn't take the space in the software, right? Okay. Good question. Is there any question more? No. Okay. Then I have a question for you. We have 2 questions now. How does in exercise 2.3, where we use the buffers, how does the 2 processes, robot, transport, and machine resources interact with each other? And what could be advantages of this current way of programming buffer? If I take a look at this one. So you can see this is the answers I provided you last at the beginning of this week, right? So let's look at this one and try to answer the two questions. Wait. Let's start. Sorry. Okay. Please go to Mentimeters and try to answer these two questions. First, how does the two processes interact with each other? Okay. Very interesting. Most of you choose buffer and two of you choose robot and machine. Who choose robots? Why do you think so? Could you speak a little bit louder?
I didn't know the answer.
Okay, you did the gambling. Good. Who choose the machine? Okay. It doesn't matter. The answer is the buffers. And why? Is there any you have the answer? Why do you think buffer? Because most of you choose buffer, right? So why do you think buffer is the connection point here? Yes? Right. Right. This is in practice. If the process follow like that, but in the code, how does it behave? How does it process? I will demonstrate to you why the buffer is the connection point between two processes with the simulation technique. Let me try to do it here. Yeah, I try to use Visual Studio Code to demonstrate why it's the connection point. You can use Google Colab, but it's better for me to use this one. So here, if I do the debugging, okay, so first it will run the machine resolve process. What it does, continue. It will go through 5 jobs. Then the robot transport process will be executed for 5 jobs. No, sorry, I took the wrong one. I think I will go to, I think it should be store here. Yes. And it should be here. Sorry, I took the wrong example, but here would be the right one. Because it's very important for you to understand how the code executed. So here, when after you start the robot transport process, it will go until it leaves the machine resource process. The transport will execute, and then it hit you here, buffer.get. What does it mean with this? It means that it will wait until the buffer has the job inside in order to get the job out. The machine process will stop here and wait until there is a job in the buffer. And if you continue, then you see the robot transport will execute until it put a job into the buffer. Then the machine resource will be re-invoked from line 36 after the get. Do you understand it? Is it clear to you? Okay. Some of you not. Okay. Then I assume that is good. Then next, what could be the disadvantages of this current way of programming buffer? Yes, sorry.
Is there similar feature
in Google Colab, you cannot do that, but you can print out when the job in the buffer by using end.now. You can detect when the job in the buffer and when the job get out of the buffer by using print function. In Visual Colab, you can see more visualization how the code runs from one line to another. Okay, and next. Okay, large number choose second, and 5 of you choose the last one. Who choose the last option? Yes. Why did you choose so? Okay, too much space with buffer. Okay. And who choose the second one? Also, you choose the second one. Okay, the second option is the correct one, but why? The question is now why the second option is the correct one with the current way of programming buffers. Is there any of you knows that? Just try to speak it loudly. Why do you think the second one is the right option? Most of you choose the second one, second option. Okay, then if you take a look at this code here, what you do in line 24 and 22 is that you ask for the uses of machine. Then you ask for the availability of the job in the store. It means that if the job is not in the store, the machine has to wait. right? All right. In line 52, you put the job, robot put the job into the buffer. But if the buffer is full, then the robot has to wait, right, until the slot is available. And after that point, the robot can be released to use for another task, right? So this way of programming makes the resource has a less utilization rate. It could be a problem. It may not be a problem, but in this one, it's advantages. So the question now is, how can you solve this disadvantages? How you can address this? Do you know how to address this problem? If you want to check the job before you acquire a resource, you ask for the resource. So what you can do is that you can move this line to here. Okay. So it means that you ask for the availability of the job in the buffer before you ask for the usage of the machine. In this way, you can increase the utilization of the machine. Literally. So when to use buffer and in which order, it really depends on the situation, it depends on the condition, depends on the exercise of on the assignment. You have to think about that and decide when and in which order I should use it. Okay. Then let's move to the practice exercise on store. So now, previously in exercise 2.3, with exercise 2 in instruction 2, last instruction, we modeled robots as normal resource. And there's an interesting question come up. Can we use another type of simple shared resources to model the robot behavior? Why? So I would like to ask you to discuss with your student next to you, your friends next to you in 1 minute, and we discuss together. Okay? Now let's start. Okay, who say yes? Yeah, just raise your hand. Who say no? It can be no. Yes. What do you think it cannot? We cannot use intuition. Okay, good. Actually, the answer is yes. Why? Because the normal resource like machine and store share similar characteristics. The capacity, the number of machine is equivalent to the number of slots in the buffer. The way you request to use the machine is similar to the way you request to put one object into the store. And the way the duration you use the machine is equivalent to the time you delay the object in the store. So the answer is yes, but I would not recommend you to do that. Because if you use store instead of normal resources, you are trying to recreate what Symbase already does with the normal resources. Because store has more functionality than the normal resource has. So if it requires you ask you to model with a normal resource, just use it. It's more efficient. Okay. Okay, now let's move to exercise 1.2. Now I assume that there's only one buffer to contain all of the jobs. Then the machine will try to retrieve a specific job that machine needs from that buffer and process them. Then the question is how we create that? How do we create that? How to request a specific job and what is the best capacities? So let's fill in the template in the Google Colab. Then we will try to answer the question in Mentimeters. Okay? You have 5 minutes to do so. Now, let's go. Can you find, yes, can you find the template? You don't have accessibility, right? Yes. Now you should do that. You should be able to do that. Can you do it again? While doing the exercise, if you have any questions, just raise your hand and we come to you, okay? Right. And in five, Okay, so the time is up. Then we try to answer some question in Mentimeters, okay? So how do we create a shared buffer? Yes, filter store is the way how to create the shared buffer. If you watch my video this week, you know that filter store is used to store different type of the objects. How do we request to get a specific job out of the buffer? Okay. The second option is the right one. We need to use lambda function to get a specific job out of the buffer. Why so? I will explain it later. Okay. So what is the best capacity? Did you already try how much capacity a share buffer should have? Not yet. You haven't reached until running that or yet. Okay. No problem. Then I will work with you through the solution, okay? So let's do that. It's very quick. So first I have to run the first two cells. Then first we have to define the share buffer with the filter store. So it's simple dot filter store and env and the capacity equal to buffer capacity. Okay. Then you have to put the job into the buffer by doing with u and share buffer dot put. Now you have to put the job into the buffer. So you have to put the parameter job. Then you request. When you request something, this means that you have to put u and then share buffer dot get. Now you have to use lambda function and job in buffer jib dot job names equal to job dot job names. Yes. If you put capacity equal to 1, what you have with the max span is 102. If the buffer capacity equal to 2, then you have 84. So the right answer is 84, equal to 2. So the 2 slot in the share buffer is already enough. Okay. But what the lambda function does here? The lambda function here is a short form of the function get job here. So the lambda function will have you to go through each item in the buffer and then define the job that the machine needs and return that job. Okay, so with one line down here, lambda, it replaces the 5 line of code here. Do you get it? Okay, then we have a short break in 5 minutes, and we can return with the second part of the section. Okay. Okay, may I get your attention? We will continue with our section now. So the second part of the section will focus on the event type. As you know that one way to model the process interaction is through the shared resources, but there also another way for modeling process interaction is through events. There are 5 types of events: the timeout event, resource availability event, and process event that you already saw more or less in the previous exercises. The custom events here is kind of event that you define. by yourself. And the combination of the above, one of these above. So the exercise 2 consists of 3 parts. The first part we will practice on the first 3 events: timeout event, resource request event, and process event. And the second one, we will practice with the custom events used to connect one process to another one. And the final is we will try to combine several events together. So let's do exercise 2.1 now in Google Colab. Then we will answer the question here. So you have 3 minutes to do so before we answer the question in Mentimeters. I think so too. Okay, the time is a bit short, but because you're already familiar with these 3 types of events, so let's answer the question here. How do we create a process event type? Okay. Then anyone want to answer? 6 already. Good. Yes, the correct answer is the first one. And I will go through with you. We'll work out a solution together. So first, the timeout event. We define the timeout event that is triggered after a certain amount of time by using n dot timeout, and you put the processing time of job of operation I here. Okay, then you wait for the timeout event to be succeeded by you job timeout event. That's how we do with this one. Previously, we merged these two lines with this one. Right? Previously, we do like this. Actually, it's a short form of these two lines. First, we define the timeout event, the promise in the future. Then we wait for the event to be succeeded. Yes? Oh, no. Yeah. Pointing out something. Then the second one, generate the machine request event or resource availability event. Then what you do is that you ask for the machine request, then you fill out the machine of the operation. Then you wait for the resource become available. And after that, you release the resource by doing so. Machines, then we have here, instead of request, we will release the machine request. Previously, what you did is that you do like this with a request, right? And you don't have this one, right? So what I'm writing here is the short form of what we discussed before. Then how to do, yes? It's just to let you know that by doing so, we create a request event. It's a short form of the previous one. You can use the previous one, but in the sake of understanding the resource availability event, I split it out. Okay. Then here we do like this. And robot transport. Then you have I, job, and robots. Then you use for this event succeeded by transport process event. That's it. And if we run it, then we should get the correct answer 88. It's because I put two robot here. If you put 3 robot here, then you should get 84. Yeah, 84. Okay. Okay, next. Now we will we will practice on a custom event that used to connect the robot transport with the machine resource process. So the question is, how do we create such event? How do we trigger that and wait for the event to be succeeded? So let's do the exercise in the template 2.2. Then we will answer the question in Mentimeters. Okay, you have 5 minutes to do that.
I have some needs for my students here. When can we actually find this instruction?
Just after the section.
Okay, lovely. Thank you very much.
Okay, no
Have a
problem.
good listen.
Have a good bye. Yes. Okay. 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 Let's answer the question in Mentimeter now. So how do we create transport ends events? Transport end events, the purpose of that one is to say, I'm done with the transport, I want to be processed on the machine. Just think, we have 3 and 3 here. Equal. 4 now. Oh, 4. Okay. The correct answer is 2 and 3. Surprising. The first one is not correct because you need to pass the parameter simple environment inside simple event. But the third one is also correct. There's 2 different ways that you can define event. Simple.event environment or end.event without the parameter. But the main question is, why do we need to create 5 transport ends events? Is there anybody know that? Okay. It's very important for you to understand that here, whenever you create one job, you start the process machine resource process, right? Whenever you create one job, you call this process, right? It means that you create 5 different processes corresponding to 5 jobs. In order to say job 1 end with the transport, I want to start to process on machine 1. You need to define one process for one event for one job. So with 5 jobs, we have 5 events. Do you get that? Okay. Then how do we wait for the transport ends event to be succeeded? Yeah. Right. Now, most of you understand why the first option should be the correct one, right? Because it corresponds to each jobs. So we need to have job names here. Okay. How do we trigger the event and mark it as successful? Yes, the second option is the correct one. Dot succeed. That is how we mark the event successful. So I will work with you throughout the solution. So here first we need to create 5 events correspond to 5 jobs. So what we do here is that we did with simple event and environment, and we have in range of the job 1 to 6. Right? Then we need to wait for the event to be succeeded. So transport ends, and then we have job name. Then we mark it successful by transport ends. Then job name dot succeed. After it succeed, because this is the first operation of the job, right? You need to transport the second operation, process the second operation of the same job. You need to recreate the event after the first transport. You recreate that by transport ends and job name equal to, you can do like this. That is how it works. I try to use 2 types of creating event to show it to you. So when you run it, yeah, you should get the same result 84 here. So the code will run like this. So first it will start the transport process. It hit this line, it stopped. It stopped until this one succeeded. When this one succeeded, it returned to this process and execute the next line here. Okay. This is how the 2 processes interact with each other through the custom event. Do you get that? Okay, you can practice more and try to debug it, and you can understand more. Next, let's move to the last one. We try to combine several events together. So let's do it in, now let's say 3 minutes. And we will answer the question in Mentimeters, and I will with you the solution, okay? It should be very similar to the previous 2 exercises. If you need any help, just raise your hand. No, no problem. Okay. Let's try to answer the question here. So how do we combine the resource availability and process events together? Okay, the second one is the right one. The third one is not correct because you don't need to use generator keyword for the same line on the same line. And how do we define when the simulation should end? The last one is the correct one. Why? Because we need to satisfy two conditions. First, when the simulation environment time exists 30 and the job tree is completed, it's defined by the sim ends event. And you have to run the simulation environment until the sim ends event succeeded. That is why the third one is correct one. I will work with you through the solution now. It's very quick. So here you need to define the simple event by simple dot event and end. Then what you do is that you need to have first condition, the current simulation time should exceed 30 or the job tree is completed. So if this one equal to 3.3, the last operation of job tree, then you mark the sim end event succeeded. Okay. And then you run the simulation until one of the two conditions is satisfied. It means it run until the sim end event succeeded. That's how it works. Here it yields the request. We combine the resource availability and transport event. Okay, when you run that, then you should get 34. So you can see it exists 30 here, then it just stopped the simulation. That's how we can define when the simulation should end based on the custom event. Okay. Then we go to the summary. So very quick. In the last 3 instruction section, we go through different simple features, including environment, process, generator. We also discussed about share resources and process interaction with normal resource, store, filter store. And just recently, we do some exercises with the event type. So we also practice with the clock inventory model, job shop, simple job shop, extended job shop, and share buffer. So we practice through different exercises. In the upcoming week, the Q&A section for simulation and case study will be online. There is a schedule in the Canvas in announcement. If you go to home page and click to online Q&A section, then you will directly go to the schedule in announcement. There will be one exception for room number 3 and number 4, group 13 to 26. Instead of 2nd of June, it moved to 31st of May because the 2 teachers responsible for this room will attend the conference. They cannot be present on 2nd of June. We reschedule that to the tutorial section you have on Tuesday. Okay? Any question left? If no, then I really would like you to fill up. Yes. Program, but which code? 2.3. Okay, good. Here. Okay. Sorry, I've done that very quick, so you cannot. So after you fill out the index card, just return to me, and then you leave the room. Okay. Thank you very much. Luckily, the score is still here.